Good evening, everyone. My name is Seamus McCaffrey, Chair of AgriSearch. On behalf of AgriSearch and our partners, AFBI and CAFRE, I'd like to welcome you to this webinar this evening. It's on a very important and topical subject on fertiliser planning for the coming spring in the background, or against the background of very significant price rises. It was in regard with this in particular in mind that AgriSearch commissioned AFBI to write a report on fertiliser planning and to help today in presenting this webinar. So with us this evening, we have from AFBI, Debbie and David, and from CAFRE, we have Aoibhinn and Rachel. The chair for this evening's proceedings is Robert Hull from CAFRE, and I would now like to hand over to Robert, who will chair the webinar. Thank you.
Thanks, Seamus. Hello, everyone. I'm delighted to chair this important webinar, and it's very encouraging to see so many people have joined us this evening. As we're all very aware, the price of chemical fertilizers has reached unprecedented levels. And hopefully by the end of this webinar, you'll have received some very useful information to allow you to make some informed decisions around how you'll plan the application of not only chemical fertilizers, but also slurries and manures, which in these days are very valuable sources of nutrients. But before we start, I need to go through some housekeeping. So you'll see the first one there, you're automatically muted, so you don't need to worry about background noises coming through to the presentations. You can use the Q&A function, so not the chat box, to answer questions. So along the bottom of your screen, you can click on the Q&A tab, which will open a text box for you to write down your question, and then you can submit it. And folks, I'd really encourage you to submit your questions at any point during tonight's event. If you have issues connecting to the event, it's probably best that you leave using the red button on the bottom right-hand side of your screen, and then use the link to rejoin. The webinar will be recorded. The purpose of this is to make it available on the CAFRE, AFBI and AgriSearch websites for anyone who misses tonight's event to catch up again. At the end of the event then, please take a few moments to complete the feedback survey. The results of these surveys are always very useful to help us gauge how the event went and what more we need to do to help you navigate around this and other important issues that you face. So housekeeping done, let's get into the program for tonight. And tonight, folks, we have 4 excellent speakers lined up. The first, Dr. Debbie McConnell, is a dairy research science at AFBI, specialising in dairy grassland research. And Debbie will present the results of a recent review of all the science behind the costs and benefits of fertiliser application to grassland. Debbie will explain what impact the increased cost of fertiliser will have on the cost of producing forage on your farm, and will let us know if it is still cost effective to spread fertiliser at today's very high prices. Our next speaker is Aoibhinn McMullen, who is a senior technologist at CAFRE. Aoibhinn will discuss the importance of assessing the nutrient and soil health status of our soils. She will explain the value of nutrients already on the farm and how, by putting some time into planning your fertiliser applications, you can maximise the impact from the fertiliser you've decided to sow. Rachel McGarrell then is a CAFRE beef and sheep advisor working with farmers in the Business Development Group scheme. Rachel will share some very good advice and go through some practical on-farm scenarios to help you decide on the best course of action for you and your enterprise. And last but not least, Dr. David Patterson, a grassland agronomist from AFBI, will end tonight's event by taking a look towards the longer term. And David will introduce some ways we can reduce our reliance on chemical fertilizers, and in particular artificial nitrogen, to achieve the yields of grass and silage that we require for our stock. Question answers will follow, so please send in your questions and we'll pick these up at that point. I'd now like to invite our first speaker, Dr. Debbie McConnell, who will discuss the results of the AgriSearch commissioned review into the cost benefits of fertilizer use. Thank you, Debbie, and over to you.
Evening, everybody, and thank you very much for the introduction, Robert. So what I wanted to do was just take about 15 or 20 minutes or so and run you through some results that we found, as Robert said, from a recent review that we've been doing in terms of the cost benefit of fertilizer application. A really pertinent question, I suppose, as we start to enter the spring and think about planning our grassland management. So I suppose just by way of background, and onto the first slide, please there, Gillian. Thanks, Gillian. So I suppose nitrogen, obviously, it is an absolutely key component in our grassland production systems. It is something that's essentially required by the plant to grow and support the high yields of grass that we can grow here in Northern Ireland. And typically in Northern Ireland, we import a significant proportion of fertilizer, about 342,000 tonnes each year. And off that, about 86,000 tonnes of that is nitrogen. So it is a key component to our systems. And because we import so much of it, obviously, we are a wee bit more exposed to fluctuations in fertilizer price around the globe. Now, as you're all very much aware, what we've seen in the last sort of 9 months has been a significant rise in energy costs. The graph on the right-hand side there shows UK natural gas prices during 2021. And you can see that really over the summer months and into the autumn, we've seen a real uplift in energy prices and peaking there in December 2021. And there has been a slight fall again in January, but still they're considerably higher than where they were this time last year. And because energy is such an important process or part of the process in fertilizer manufacture, then this has had a really direct impact on the fertilizer manufacture process, particularly in Europe. And on top of that as well, we've had a bit of a perfect storm of things coming into play in the fertilizer manufacture process, because we've also had COVID disrupting both the production and transport infrastructure of fertilizers. And on top of that, we've seen global reduction in fertilizer exports from places like China, where they've reduced fertilizer manufacture due to rising coal prices, and Russia has decreased its export as well. So overall, we are seeing rising energy prices, and that has led quite significantly to rising fertilizer prices. If we move on to the next slide, please, Gillian. So what we've seen really since autumn 2021 and into spring 2022 is that significant rise in farm gate fertilizer prices, and that's been felt right the way across the globe. The graph on the right-hand side shows fertilizer prices running from about 2006 through to 2021, with the last data in here in October 2021. And you can see at that stage, fertilizer prices are getting up really to the highest they've been for at least the last 10 years. Not quite as high as 2008 levels yet, but still a marked increase from where we have been in recent years. Now, it's very hard to predict what will happen going forward, and there is a high degree of uncertainty around prices for the 2022 season. But short term, I think it's fair to say that prices are still remaining high for the springtime. And so with that in mind, we wanted to ask a couple of key questions. What impact does the cost of forage production or cost of this rising fertilizer price have on forage production costs? Is it still cost effective to spread fertilizer at these higher prices? And then if we are going to spread, how do we maximize the value of that fertilizer? Next slide, please. So firstly, taking the first one of those, what impact does that increasing fertilizer price have on the cost of forage production? Well, when we look at the costing or putting down on paper how much it costs to produce a tonne of dry matter or forage, be that either grazed grass, 2-cut or 3-cut silage, fertilizer typically accounts for around 25% of the cost of grazed grass. That's full economic cost, so there's a land cost included in there as well. 12% of a 2-cut silage system and 18% of a 3-cut silage system. It is higher in grazed grass because when we look at the nutrients in that system, more of those are coming from fertilizer, whereas slurry has a bigger role to play in 2 or 3-cut silage systems. So the grazed grass is a wee bit more exposed to that rise in fertilizer price. And so as we see can fertilizer prices increase from about £300 to £600 a tonne, we're seeing roughly somewhere between £11 to £22 per tonne increase in production costs, be that of either grazed grass or grass silage. So what does that mean for a typical farm? Well, if we take a typical 20-hectare grazing platform, that accounts to an additional expenditure of about £4,500 per year. And on a silage platform, again, about 20 hectares, we're talking about £2,500 or just shy of £4,000 per year under 2 or 3 cut silage management systems, respectively. So it is adding a significant cost to our forage production systems. There's no doubt about that. Next slide, please. So I suppose then one of the things that we wanted to look at was actually a nitrogen response to fertilizer, and a way for us to assess really how economical it is to still spread fertilizer at these higher prices is to look at the nitrogen response. And a nitrogen response curve, and it's that graph that you see on the right hand side of the screen, is basically a curve which tells us for every kilogram of nitrogen fertilizer that we apply, how much grass are we going to get back in return. And you can see if the shape of the curve there on the right hand side. So it's linear at the start. So as we move from 100 to 200 kilograms of nitrogen per hectare, our grass dry matter yield increases quite significantly. But as we get to higher rates of nitrogen fertilizer application, it does level out. So if, for example, we look at this 3 stars there at 150 kilograms of nitrogen per hectare, for every kilogram of nitrogen that we're applying there, we get about 26 kilograms of grass back. As we apply higher rates of fertilizer, say 300 kilograms of nitrogen, which is the 2nd star, for every kilogram of N we're applying, we're only getting 15 kilograms of grass dry matter. So it's less cost effective to be applying fertilizer in that scenario. And then once we move up to 450 kilograms of nitrogen per hectare, for every 1 kilogram of nitrogen we're applying, we're only getting about 5 kilograms of grass dry matter back. So in that scenario, certainly definitely a big impact then on the cost effectiveness of that fertilizer at those higher rates. So really what we see from the graph is as fertilizer application rate increases, the nitrogen response rate decreases. And there's particularly once we go over 300 kilograms of nitrogen, there's quite significant reductions in that nitrogen response. And that's because at those higher nitrogen application rates, other factors become more limiting again. Things like temperature, soil moisture all have a role to play then in sort of curbing that potential growth and uptake of that nitrogen. But really on average, what we see over the course of the year is that from our grass check data, we looked at over the past 10 years, our average nitrogen response rate for from 1 kilogram of nitrogen fertilizer is roughly about 20 kilograms of grass dry matter. So for every 1 kilo of fertilizer we're applying, we're getting about 20 kilograms of grass dry matter back. But that said, grass growth response to fertilizer is influenced by a whole range of factors, and it can vary quite significantly between farms and seasons. And we'll come back to that a little bit later on. So I suppose the question then that we wanted to ask was actually, if we get 20 kilograms of grass dry matter for every 1 kilogram of fertilizer applied, is the value of that grass better, worth more than what it costs to apply that 1 kilogram of nitrogen fertilizer? And if we move on to the next slide, please, Gillian. And so what we did was we just compared the cost of these. So the amount of grass produced for every kilogram of nitrogen fertilizer versus the cost of that fertilizer. And we looked at the relative feed value of that grass. So effectively what it would cost for us to buy in the same amount of energy that grass provides as concentrate. So in that, we used various assumptions: a concentrate price of £270 a tonne, a grass quality of 11.3 ME, which is our grass check farm average of the last 3 years, and a grass utilisation rate of 80%. And we put those in a ratio, and when we got values greater than 1, what that meant was the grass feed value that we get is greater than what it costs for us to apply that fertilizer. Once those values fell below 1, our grass feed value produced was less than that of the fertilizer cost. So if we move on to the next slide, Gillian. So when we did our first sort of set of analysis, what we can see was that as the fertilizer price rises, the grass value feed cost ratio decreases. So on the graph on the right hand side here, we have canned fertilizer cost on the bottom running from £300 a tonne to £1,000 a tonne, and we have our grass value to fertilizer cost ratio. And you can see that as the canned fertilizer cost increases, so as our fertilizer cost rises, the ratio falls. So when we have CAN at £300 a tonne, we get roughly about 4.9 times the feed value in grass back, 4.9 times that of what it costs us to buy the fertilizer. So we're getting really good return against what we're spending on fertilizer there. When CAN value increases to £600 a tonne, that drops, and we're only getting about 2.5 times the feed value out compared to the cost of the fertilizer. But so what we're seeing that is that as application rate increases, the grass value fertilizer cost ratio decreases, which is as you expect. However, interestingly, all of the curves in this scenario still remain above a ratio of 1. So in all curves, we're still getting a higher level of grass feed value compared to the fertilizer, what it's costing us to apply that fertilizer. And you can see that because neither of the two lines, be that either 150 or 200 kilograms of nitrogen per hectare application rates, drop below into that blue area on the graph. If we move then on to the next slide, same scenario, but again, we costed urea this time. Oh, sorry, if we can go back one, please, Gillian. Brilliant, thanks. So in this scenario, we looked at urea price again from 300 to £1,000 a tonne for urea, and we can see at about 400 kilograms or £400 per tonne, sorry, for urea. Grass value was about 6.4 times greater than the fertilizer cost, so getting really good value for money. Once we move to £800 a tonne, we're still seeing a grass value 3.1 times that greater than the fertilizer cost. So again, seeing significant value there relative to the cost of the fertilizer application. So those curves still remaining above a ratio of 1. Next slide, please, Gillian. So in both those scenarios, so far, we are getting a positive response from applying grass, but in that scenario, we modeled a fairly good conditions, and that was using data, fairly good conditions in terms of the grass utilization, correct soil pH. But as I mentioned earlier on, there are a number of factors that can affect grass nitrogen response or grass response to nitrogen fertilizer application. So things like soil health, for example, sward composition, if we have docks, if we have creeping bent in the sward, more native grasses, they will not respond to nitrogen in the same way as perennial ryegrass, and the modern day varieties that we have are bred to do so. So we will see a lower nitrogen response there and lower value for money when we apply that fertilizer. Application conditions at the time can have a strong impact on how much nitrogen fertilizer is used, and grass utilization rates as well. So just to take a couple of those by way of example, if we move on to the next slide, please, Gillian. Firstly, if we look at the impact of soil health on the cost benefit of fertilizer application, well, grass response to nitrogen fertilizer can be impeded by a whole range of things. It could be down to poor soil structure. We know that when we have compacted soils, what we tend to see is we get more nitrous oxide lost to the atmosphere, so there's less nitrogen being used and turned into plant growth and increasing grass yield. Soil pH status, I'll come back to that in a second, and also limited biological activity. So if we don't have a healthy soil from a biological perspective, we won't see that effective working of the soil and allowing the plant to take up nitrogen fertilizer. But when we focus on soil pH, some work done down at Chuggas has shown that soil pH, the lower it is, it can really reduce the cost effectiveness of fertilizer application. Some data from Michael Egan down in Chuggas has shown that at soil pH, say of 5.0 to 5.5, you can see the red lines there, nitrogen utilization in fertilizer that's applied drops to 77%. In fact, we're wasting about 32% of the fertilizer, of the total fertilizer that's applied in that scenario. So, and then that can have a significant impact on the cost benefit of fertilizer applications, because when we are applying fertilizer, regardless of what rate it's at, we can see that the cost benefit ratios that we're getting back are lower than what we had in our original graphs. So when CAN goes to £600 a tonne, say we're applying 150 kilograms of nitrogen, we're down to a cost to a feed value fertilizer price ratio of 2. If we're applying 200 kilograms of nitrogen per hectare, that value falls to 1.8. So we are starting to reduce the effectiveness or cost effectiveness of the fertilizer we're applying at those low pH values. Moving on to the next one, please, Gillian. And grass utilization as well can have quite a significant impact again on that grass value fertilizer cost ratio. When we look at different grazing systems, in our original scenarios, we modeled those at 80% utilization, because from our grass check farms, we see utilization rates of 80 to 85% on those farms. So really strong, good utilization rates. But we know that some information from HDB, which suggests set stocking to be somewhere between 40 and 50% utilization, rotational grazing 65% utilization, and paddock grazing 80% utilization. And I've just modeled sort of 3 different levels of grass utilization: 50%, which is the blue line, 65%, which is the purple line, and or the orange line, which is 80% utilization. And you can see there the blue line is significantly lower than the orange line. So as our grass utilization drops, be that through poor grazing, not having enough grazing infrastructure to really allow us to utilize that grass, we can see that the cost effectiveness of that fertilizer drops. So our grass value can drop at a fertilizer price of around £600 a tonne from a grass value feed cost ratio of about 3, and that's dropped to just under 2. So we are impacting there on the economic return that we get from that fertilizer. Next slide, please, Gillian. And finally, just to finish, we also see an impact really of the time of year, or I suppose application conditions, on the cost benefit of fertilizer application. We had a look at the grass check data, and what we can see, we looked at sort of typical nitrogen response rates, or grass response rates to every kilogram of nitrogen fertilizer that we applied throughout the grazing season. And that's taken from data over the last 10 years from plots applied here at Hillsborough and at Greenmount. And you can see from the table in the bottom left there, as we go through the different months of the year, around May and June time, and even into July, is when we get our peak grass growth response rate, because at that stage, soil temperature and light aren't inhibiting grass growth to the same extent as they are in March and April. When we get into those cooler months, on average, we see a grass growth response rate. We've only recorded a growth rate response of about 4 kilograms of grass dry matter for every kilogram of nitrogen fertilizer applied. And you can see then when urea costs 400, 600, even 800 pounds a tonne, then the grass feed value fertilizer price ratio is dropping below that critical value of 1. So we are spending more on fertilizer there than the value of the grass that we're getting back. But that said, there's increasing volatility now within seasons, and we've all seen that the last couple of years. So Gillian, if you move on to the next slide, please. We looked then in more detail at different grass growth rates in the months of March, and we can see that we've got grass growth rates anywhere between 2.5 kilograms of dry matter per hectare per day, or in very good conditions, 35 kilograms of dry matter per hectare per day in terms of grass growth. And so when we're in that scenario where we have really good grass growing conditions and 35 kilograms of grass dry matter per hectare per day, then those figures look a lot different in terms of that grass feed value to fertilizer price ratio. Equally though, in July, when we expect to get really good response out of our nitrogen fertilizer, we can see the opposite. We looked again at the grass growth rates over the last 10 years, and we had sort of growth rates down as low as 17 kilograms of grass dry matter per hectare per day, recorded back in 2018 in the middle of the drought, and peak rates of about 93.4 kilograms of dry matter per hectare per day. So growth at this stage really being limited by the availability of soil moisture and how much rainfall there is. So I suppose maybe rather than focusing on month per se, it's about looking at the application conditions, or the conditions in and around the time of application and in the following couple of weeks as well. And I suppose the best way to do that, there's weather data that's published on the Grass Check website, so you can see conditions across the board, including soil temperatures, particularly for this time of year at each of the Grass Check farms. But in the grass growth forecast published by Grass Check as well, they take into account the weather conditions for the coming 14 days, and that will give an indication in terms of likely grass growth rates. And from that, we can make a call as to whether that nitrogen fertilizer is going to then be effective, or it is a bit more risky to spread. So just on to the next slide, please, Gillian. So I just want to finish up there, but I suppose by way of summary, really, recent fertilizer price increases, it's very clear to see have had quite a significant impact on the cost of producing both grazed grass and grass silage as well. But despite that, when we modelled it, it's very clear that good quality grass does remain the cheapest feedstuff available to Northern Ireland farmers, and the ratio of grass value to fertilizer cost is still positive in nearly all of those cases, or in most of the cases. That's because we have got a high cost of alternative feeds that we're, is replacing that grass if we don't choose to grow it by reducing our fertilizer rates. However, with the increase in fertilizer price, very significant, it is very important to ensure that we're maximising grass response from any fertilizer that we do choose to apply. And the way to do that is obviously through the likes of making sure our soil health is there in terms of soil pH, soil structure, etc. Looking at when we're timing our fertilizer application so that the conditions there support good grass growth, and then that we're focusing on improving our grass utilisation as well. Thank you very much. I'll hand back to Robert at this stage.
Thank you very much, Debbie, for that really interesting presentation. There's some great information there on the benefits of sowing fertilizer, but I suppose the critical importance then of making sure it's utilised and sowed in the right conditions. I'm sure all our participants tonight will have plenty of questions for you, and folks, please continue to submit your questions using the Q&A button there at the bottom of your screen. Our next speaker is Debbie McConnell, who is a senior technologist at CAFRE. Debbie will discuss the importance of nutrient management planning to get the best use from artificial fertilizers and animal manures. So thank you, Debbie, and over to you.
Thank you, Robert, and good evening, everyone. From a nutrient management point of view, I'm going to take you back to the basics of soil fertility and look at the importance of carrying out an assessment of soil nutrient and soil health status, the nutrient value of slurries and manures available on farm, and the advantages of using a fertilisation plan. We'll also look at how to apply nutrients to optimise their potential and achieve maximum effect, and cover the key rules and regulations to be mindful of when applying nutrients. Next slide, please, Gillian. Soil analysis has never been more important and is a starting point for working out your crop nutrient requirements. Knowledge of basic soil fertility will allow you to correct pH and maximise the use of slurry and target manures at low phosphorus and potash index soils where they are most needed. A soil analysis service is provided through the DAERA Direct offices. Simply phone or email your local office to order a sampling kit or borrow a soil auger. It is recommended that you sample every 4 years, taking random cores across a field or group of fields up to 4 hectares in area. Next slide, please, Gillian. Following from what Debbie has said, this slide shows the effect of fertilizer efficiency. As pH increases from 5 to 6 to 6.5, a greater percentage of the nitrogen, phosphorus and potassium applied will be utilised by the plant, and less fertilizer will be wasted. In the right-hand column, you can see the potential financial loss resulting from the application of 150 kilograms of nitrogen per hectare of a 2744 fertilizer on a low pH soil. This is a significant cost at today's fertilizer prices. Analysis of recent soil results across Northern Ireland shows that over 60% of soil tested are below pH of 6. And the message simply is, if you don't have an up-to-date soil analysis, how do you know what your pH is? Next slide, please, Gillian. As Debbie has said, soil structure is also very important. You don't want anything to impede growth this year. So if you have areas of poor grass growth, get the spade out. Look for compaction, panning, or other causes of poor soil structure. Soil structure directly affects the movement of air and water through the soil profile, which in turn affects biological activity, crop establishment, root development, and tolerance to environmental stress, such as drought, which was experienced in some parts of Northern Ireland in recent years. Doing a simple earthworm count can be an indicator of the health of a soil and the level of biological activity within the soil. By doing a sward assessment, potential yield loss can be identified. For example, problems with field drainage or weeds such as unproductive grasses or perennial reeds should be identified. And be aware that these weeds are feeding on the nutrients in the soil and will ultimately reduce grass yield. Short-term action should be taken to rectify these problems where possible, such as unblocking drains or controlling weeds. Next slide, please, Gillian. Organic manures such as slurry, farmyard manure, poultry litter, and anaerobic digestate are all valuable commodities this year and should be assessed in terms of the nutrients that they will supply. Using standard figures and looking at a typical 6% dry matter slurry, we can see that 1 kilogram of nitrogen, 0.6 of phosphate, and 2.3 kilograms of potash are supplied in every cubic meter of slurry. This equates to 9 units of N, 5 of P, and 20 units of K in every 1,000 gallons applied. This is assuming spring application using low emission spreading equipment and nitrogen availability at 40%, phosphate at 50% on P index 2 or greater soils, and 90% potash availability. Next slide, please, Gillian. Now, last year, I was telling farmers that they needed a fertilisation plan to fulfil the requirements of the Nutrients Action Programme and to comply with the regulations. This year, the emphasis has changed. Now, it's also essential to have a fertilisation plan to show when, where, and how much manure and fertiliser to spread. The CAFRE crop nutrient calculator satisfies the NAP requirements and provides farmers with a simple and easy to use fertilisation planning tool. The calculator is available on the DAERA online services and can be accessed via your government gateway account. Next slide, please, Gillian. Within the calculator, step 1 is entering your field details and soil analysis results. And then step 2, select the crop, for example, grazing, silage, or any arable crop. The manure and fertiliser function highlighted provides an instant crop recommendation and allows you to input various combinations of organic manure and or chemical fertiliser to be applied during the season. Next slide, please. The calculator will provide the maximum crop recommendation for your chosen crop. In this case, I've used a beef and sheep grazing example on a P index 2- and K index 1 soil. Please note this is the maximum recommendation to achieve the highest yield for the grazing season. Here, aiming to achieve between 12 and 15 tonnes of dry matter per year. If you're expecting a lower yield, then you can apply less nutrients. So it's important to match nutrients applied to crop yield, as excess nutrients will be held in the soil or more likely lost to the environment. Next slide, please. This section allows you to add organic manures. You can select the type of manure, the volume to be applied, and the method of application, such as splash plate, dribble bar, or trailing shoe. The timing can be chosen then, either spring or summer, and so on. This allows you to compare nutrient availabilities and will help you to maximize the potential of your slurry. If the type of manure you're using is not listed, you can enter the nutrient analysis in the section Other Organic Manures. Next slide, please. Similarly, to top up with chemical fertilizer, select the type of fertilizer from the drop-down menu and enter the quantity applied in kilograms per hectare. Next slide, please. Here we can see the total nutrients to be applied throughout the season from slurry and from straight nitrogen fertilizer. The bottom line shows the balance of nutrients to be supplied in this instance. Had we oversupplied any one of the 3 nutrients, the system would state oversupplied and highlight this figure in red as a warning. In this case, nutrient application has been matched to the expected yield for a less intensive grazing system. Research has shown that at low stocking rates and low levels of nitrogen application, lower rates of phosphate can be justified. Next slide, please, Gillian. When all field areas and crops have been entered, a summary report can be downloaded. This provides a table showing the total amount of slurry to be applied across the whole farm and the quantity of each chemical fertilizer required for the season. This will be a very useful tool to plan and budget fertilizer purchases this season. In this example, slurry has been maximised, chemical nitrogen has been used to top up the nitrogen requirement, and compound fertilizer will be applied when required. And Rachel will go into some more detail on using a farm scenario in the next presentation. Next slide, please, Gillian. When it comes to application, be guided by the weather. Apply when soil temperature reaches at least 5.5 degrees to a depth of 10 centimetres and no frosts are forecast. Grass growth has commenced. The AFBI grass check is a useful asset to monitor grass growth. Applying slurry in spring will result in better utilization in comparison to late summer applications. So aim to hit grass at the start of the season as grass growth starts and have nutrients in place for peak grass production as the season progresses. Also, don't apply when rain is forecast for the next few days. There's little point in applying nutrients where there is risk that they could be washed into the waterways where pollution could be caused and valuable nutrients are lost from the field where they are actually needed. Using low emission slurry spreading equipment will reduce ammonia emissions and increase nitrogen efficiency. Research shows increases in efficiency when using a dribble bar and further increases if using trailing shoe. Low emission also allows the application to heavier grass covers, particularly with the trailing shoe where the grass is parted and slurry is placed close to the ground and there's less risk of sward contamination. Regular maintenance of the working parts of slurry and fertilizer spreading equipment is important to ensure correct application. Very often, calibration of spreading equipment is overlooked. Now, Teagasc have developed a very simple phone-based slurry calibration tool based on the time required to empty a tanker, the tanker size, and bout width to determine the required forward speed of a chosen application rate. So accuracy of application can be improved with the use of technology such as border limiters, GPS guidance, and variable rate application, technology which some farmers and many contractors are now making use of. Next slide, please, Gillian. Just to remind you of the relevant NAP regulations, take care to observe buffer zones or no spread areas around fields. Stay at least 2 meters from all water courses when spreading chemical fertilizer and 10 meters for organic manures. This can be reduced to 3 meters if using low emission slurry spreading equipment. But remember, these distances for slurry spreading increase during the month of February to 15 meters for slurry and 5 meters if using low emission. Also, the maximum application rates are reduced from 30 cubic meters per hectare to 2,700 gallons per acre. A fertilization plan is required if applying chemical phosphate fertilizer to grassland. High P manures such as pig farmyard manure or poultry litter from laying hens or broiler breeders, or anaerobic digestate to any land. A fertilization plan must show that there's a crop requirement for the identified P index from a recent soil analysis. Next slide, please, Gillian. So the take-home messages are that if you haven't already done so, get out and take some soil samples. Use this information to create a fertilization plan. And the next evening you're registering calves or on using APHIS, use the crop nutrient calculator and try to work out what fertilizer is required for your farm. And always target your manures where they are needed most and apply chemical fertilizer to top up any nutrients where they are required. Thank you.
Many thanks, Aveen. Thank you for that. Yep, thanks for highlighting the financial cost of sowing fertilizer when the soil nutrient and soil health statuses are below optimum, and for demonstrating how easy the CAFRE nutrient calculators are to use and how useful information coming out of them is. Our next speaker is Rachel McConnell, who is a CAFRE beef and sheep advisor. Rachel will discuss the need for farmers to plan ahead and work to achieve target yields of graze, grass, and importantly silage crops to make sure you have enough fodder to get you through next winter. Thank you, Rachel, and over to you.
Thank you, Robert, for your introduction, and good evening, everyone. So tonight I'm following on from two very informative presentations from both Debbie and Aoibhinn. And within my own presentation, I really want to try and reinforce the messages that have been highlighted this evening, but in a practical way that can be translated on farm. Next slide, please, Gillian. So the burning question at the minute is, do we really need to sow fertiliser? Well, in short, the answer to that is yes, if we want to achieve target silage and grazing yields. So it's very important in terms of achieving the growth that's required in order to graze our livestock, but also to grow enough silage to be able to fodder them over the winter months. And the key here is that every kilo of fertiliser purchased must count. So given our present circumstances in relation to cost, this is more important than ever. You must use your fertiliser efficiently, and if you do so, you're going to achieve a good grass growth response. Now, Debbie has already shown that it is cost effective to still sow the fertiliser, but you must ensure conditions are correct and you must sow at the correct rate also. If you think about the consequences of not sowing your fertiliser, you're not only going to limit grass growth and grass yield this year, but also think of the lifetime value of your sward also. It can allow other more unproductive grasses to invade and dominate the sward, and that's going to affect both your yield and your quality. So if you've gone to the expense of reseeding, then obviously you want to try and protect that investment as much as possible. So the key here is to aim to use your fertiliser that you have purchased, but use it in a smart way across your farm this year. Next slide, please, Gillian. So when I was thinking about what I would say this evening for the presentation, I got to thinking about inefficient fertiliser uptake that I see across farms that I work with. And the first one here relates to the inappropriate timing and application of your inorganic fertilisers. So your fertiliser may have been applied when grass response was poor, for example, in early spring or into very late autumn time. Fertiliser may have been applied during periods of very dry weather, so there was insufficient moisture to allow effective utilisation of your grass and for growth to take place. And then again, the opposite may be true in times of very wet weather and excess leaching may have occurred, so that fertiliser was really lost from the soil. The second one here relates to the timing and application of your slurry and manure. We've been conditioned to think of slurry and manure as a waste product and something that we're obligated to store, but now we really need to review our thinking around this and really focus on the nutrient value of those slurries and manures. So if they're applied when conditions are unsuitable, then you're going to lose all the nutrient value there. And as a result, you need to top up with more expensive inorganic fertiliser to meet the needs of your crop and for the growth of that crop. So don't underestimate the value that's in your slurry. Make sure you're putting it on at the right time, at the right rate, and using the right equipment. If your soil pH is too low for good grass growth response to fertilisers, again, your money is wasted. Aoibhinn has already shown this. She has shown how pH really can be, it can reduce the pH Aoibhinn has already shown how much uptake is reduced if pH is below the optimum level. So, I mean, that can have a significant impact on you financially. So it's just something to be aware of. Your soil type, lots of different soil types across Northern Ireland. And if you're on a shallow sandy soil, for example, then your soil may be prone to more excess leaching, so your nitrogen can be lost there as well. The previous speakers have touched a little bit on the quality of your sward. So we're thinking of swards that have a high percentage of perennial ryegrass there. And when the perennial ryegrass begins to decline, weed grasses come in and they begin to take over, and they are much less responsive at higher nitrogen levels. And then finally, we're thinking of our grassland management, and that's essential if we want to get a good response from our fertiliser and we want to increase utilisation of our grass. So there's no point growing your grass if you can't get our livestock to use it appropriately. So the key is to graze at the right time and using the right amount of stock, really. Next slide, please, Gillian. Forward planning this year more than ever is going to be essential, and what we want to try and do first and foremost is think about a winter feeding strategy. So one of the first things you need to consider is how are you going to feed your livestock over the winter period. Remember that your grass silage still forms the mainstay of our feeding systems in Northern Ireland, so we need to try and manage our fodder supplies to meet our animal requirements over the winter months. The key here is estimate the amount of silage required for the various classes of livestock that you have on farm at that point in time. Once you've done that, think about a sales plan for the stock that you currently hold on farm. For example, if this year your plan is to sow less fertilizer, then you need to be aware that grazing yields are going to be reduced and also silage yields are going to be reduced. So are you planning to sell stock earlier than you usually would? Otherwise, are you going to be halfway through the winter and you don't have enough fodder? So once you've thought about that, then think about the quality of the silage, and don't forget about quality, because it is essential also. In terms of your calving pattern, if you're working with a high input, high output system, then you need to focus on quality. So thinking about maximizing the D value of your silage, and think about maximizing the ME. An autumn calving cow, for example, is going to require higher quality silage than a spring calving cow. So keep that in the back of your mind at all times. If we think of winter beef finishers, for example, again, they're going to be pushing for high quality silage. We want to try and get the maximum daily live weight gain for as low a cost as possible. Thinking of our land type again, and just like our soil type, lots of different land types out there across Northern Ireland. And if we think potentially of someone who's on wetter, heavier type soil, this may have an impact on when they can get their first cut lifted. So that will then impact on the number of cuts that can be taken potentially throughout the growing season. And then finally, thinking of your sward type, your qualities and types of grasses and the varieties that are in your sward will determine the quality of the silage that is made also. It can also determine the quality of when you take your first cut, and then the number of cuts that you're able to take throughout the season. So a lot of this is very much individual to your own farm level, but there's lots of variables that you also need to take into consideration. Next slide, please, Julian. So I've spoken about how important it is to put a plan in place, and part of this plan is going to be a fodder budget, and that's going to be required for the stock that you plan to keep over the winter period. So a fodder budget is something that's very, very simple to do. And on the screen here, you can see a very simple example of 180 ewes, 40 suckler cows, and 40 followers being held through the winter months. So we have our daily silage requirement per head. We have an approximate housing date, an approximate turnout date, and then we have worked out basically the monthly requirement and then converted this into an overall requirement. So if we're being very precise, we need 488 tonnes of fresh weight silage to see those animals through the winter period. Obviously, we're going to put a bit of a buffer in there, and we're going to round that up to 500 tonnes. Next slide, please, Gillian. So we know how much fodder we need. The next thing we need to consider is how we're basically going to make this silage. We're thinking of a beef and sheep farm, so an average scenario. We're thinking of a first cut yield 8 tonnes per acre, average second cut yield of 6 tonnes per acre, and that's a total of 14 tonnes per acre required to meet those animal requirements, and that's on a fresh weight basis. So how much land do we need to cut? Well, exactly, we would need to be cutting 35.7 acres twice. However, again, that would be difficult to achieve. So we're going to round that up, put a bit of a buffer in there again, and we're going to cut approximately 40 acres of silage twice. Within this example, I should say that we're assuming this is a good quality grass sward, so it has been reseeded, say, in the last 3 to 4 years. The pH level is correct, and your P and K levels are at optimum. So therefore, any slurry that we put on meets crop need. And this has been identified via a valid soil analysis report, which has been done in the last 2 to 3 years. Next slide, please. So we've worked out how much we need in terms of silage to fodder those animals over the winter. Then we've looked at the silage area that needs to be taken out. And now we're going to look at the fertilizer requirements. So for our first cut, we're going to think about applying 120 kilos of N per hectare, or 96 units per acre. We're going to go on with 2,000 gallons of slurry in good conditions via lessee, and that's going to contribute approximately 22.5 units of N per acre. So that leaves us 73.5 units of N to be applied using our artificial fertilizer. So because our slurry is meeting our P and K needs, we're going to go on there with a 27% fertilizer. And for first cut, we're going to apply 2.7 bags to the acre. Moving to second cut, then we're going to look at putting on 100 kilos of N per hectare, or 80 units per acre, 2,500 gallons of slurry again in good conditions via lessee. Now we want to try and get this on as quickly as possible after your first cut has been harvested. Again, we're hoping to contribute approximately 22.5 units of N per acre. This leaves 57.5 units to be topped up using our 27% N fertilizer. So we need to apply 2 bags to the acre. So in total for first and second cut silage, we need 4.7 bags to the acre. Next slide, please, Gillian. We've worked out how much fodder we need for the stock. We've looked at how much silage ground we need to cut. We've looked at the fertilizer we're going to put on. And I suppose the big question is, how much is it going to cost to grow this crop? Based on our previous calculation, we know that we need 4.7 bags per acre to grow our 2 cuts of silage. So if we think back to 2021, 27% N was £300 per tonne, so that was equivalent to £15 per bag. In 2022, it has now risen to double that amount, so it's £600 per tonne, equivalent to £30 a bag. So if we take our 4.7 bags that are applied per acre for our 2 cuts, at £30 per bag, that's costing us £70.50 per acre. We're aiming to achieve 14 tonnes of fresh weight silage in the pit per acre. So £70.50 divided by our 14 tonnes, it's costing us an extra £5 per tonne to grow this crop. So in total, we need 9.4 tonnes of 27% N fertiliser at £600 per tonne. So £5,640 of fertiliser to be purchased. So the question I have for you is, can you afford to do this? Do you have the funding in place to allow you to do this? The other side of the coin is, can you afford not to do this? If you don't do it, what's going to happen? So if you don't put fertiliser on, or you reduce your fertiliser drastically, you could be in the scenario where halfway through the winter you have run out of silage. You're trying to go out there to source silage. It's much more expensive. You may have to go in there with concentrate feed, which again is creeping up slowly. Every month we're seeing rises. So be mindful of that as well. If you take the fertiliser out of the system, you have to replace it with something else. If we even drop this down to a per cow basis, if we think of a farm, a heavy farm, and they're housing their animals, say, for 7 months of the year, and your cow eats a tonne of silage a month, that's 7 tonnes to keep her over that winter period, and it's costing an extra £5 to grow that crop. So that's an extra £35 really to winter that cow. So can you afford to do this? Is the market going to return that to you? Well, that's the unknown question. Next slide, please. I've talked a lot this evening about grazing, or about silage, and now I want to touch on grazing. And we obviously need to ensure that we're making the most of our grazed grass. We're very good at growing grass in Northern Ireland, and something that we need to exploit to the best advantage. Grass is really our most important resource. So in order to make the most of it, the first thing we need to know is how much grass the farm is capable of producing, and also how much grass we need in order to feed our livestock. So what can you do? What practical things can you do? Well, I would think about the implementation of a paddock grazing system. It's something that can potentially work very well on your farm. Work with your CAFRE advisor if you're in a business development group, and they can help to get you started on this. They can help you to introduce a structured grazing system which complements the use of the plate meter and the associated grass management software. So it really is a case of measure to manage. Think of applying your nitrogen in correct conditions at the right time and within the grazing season to achieve the best response. Think about planning your grazing early on. Consider any scope that you have to extend the season, really at the shoulders of the season. Can you get animals turned out earlier? If you think about it, later turnout leads to heavier grass covers, which are harder for the animals to utilise, so utilisation then overall is lowered. If you're planning for early turnout, I suppose the key is to be flexible, keep your group sizes small, and be prepared that you may have to bring animals back in, or you may have to do on-off grazing for a little while. And the last one I have on here is think about compaction. So if you have areas in your farm that have been heavily poached, or areas in the farm that have been heavily trafficked, for example, with machinery, then get out with your spade, dig a test pit and see what's going on underneath the soil. So really, when you're thinking of soil compaction, it increases the density of the soil. It means the roots are less able to penetrate down through the soil, and they're generally shallow. So because of that, growth is then restricted. So the plant essentially is less able to exploit the soil for nutrients and moisture. So that in turn means that there's a lower response to the fertiliser that you have put on. Next slide, please, Gillian. This is quite an interesting table. It looks at grazing system, yield and utilisation. So it illustrates the potential increase in terms of usable grass yield on a rotational system versus a paddock grazing system versus a set stock system. The research studies have shown that more grass is grown and utilised in a paddock grazing system. So you can see here almost twice as much grass is grazed in the paddock system than the set stock system. So if you consider your traditional set stock system, animals remain on the same area indefinitely. Any regrowth that comes through is constantly being grazed and nipped off by those animals, whereas in a paddock grazing system, the animals are moved on frequently. They move through a series of paddocks which are based on measured heights or measured covers, and they're usually grazing in a paddock for approximately 3 days, and then they're completing the rotation over approximately 3 weeks. So the rule of thumb, graze for 3 days and then rest for 3 weeks. And this targets the best time to graze your grass plant, which is when it is at the 2.5 to 3 leaf stage. Next slide, please, Gillian. And again, this is an interesting one also. You should really be paying attention to the grass growth curve. And throughout this evening, all of the speakers have discussed the importance of the correct timing of fertiliser. And this graph, produced by the GrassCheck NI data, shows the red line for 2021. Now, I appreciate 2021 was a difficult growing season. So if I can draw your attention to the blue dashed line, which shows the 10-year average, you can see where growth begins to take off throughout April and then peaking in mid-May. Usually at this time of the year, especially on a beef and sheep farm, we go from really a bust scenario to a boom scenario in terms of grass availability. All of a sudden the grass is there and we're not really that sure how to manage it so well. And people at that point tend to hold back from putting any additional fertiliser on. But really, if you think about it, this is when the grass plant is actively growing and can really utilise any N that you put on. So don't be afraid of having those excess covers. They can be taken out of your grazing platform for extra silage, and that can come in quite handy this year especially. So, you know, don't worry about doing that, and that's a way that you can maximise efficiency and utilisation of your grass. I should also say that this graph is produced by GrassCheck, which is operated by AgriSearch and AFBI. It monitors grass growth weekly, grass growth and quality weekly throughout the province across farms. It provides a growth forecast, which is really useful. And the bulletin is available in the Farming Press and also on social media. So it is something that you should keep an eye out for and pay attention to if you see it. Next slide, please. So if I was in the audience this evening, I would be thinking of asking myself a number of questions. And one of the big ones is, do you know how much fertiliser you used last year and how it was distributed across your farm? And you might think that's a silly question, but it's not. When I'm on farm, I see both sides of the coin. I see the farmers who know down to the last penny and down to the last kilo how much fertiliser came onto the farm, how much was sown and where it was sown. And then I see the other farmers who they're not just that sure. And this year, you can't afford to be the farmer that's not that sure. You need to be the one who knows down to the last penny what has been happening with that purchased fertiliser. Do you know how much grass your farm is growing per hectare? And again, you can do this by the implementation of your plate meter. You know, it is something that farmers are seeing a real benefit in. So we have seen an increase in people in uptake within our business development groups in terms of grass measuring and use of grass software such as AgriNet. Is the artificial nitrogen that I'm purchasing and applying working as efficiently as it could? Well, that really goes hand in hand with the pH status of the soil. And I know Aoibhinn and Debbie have both touched on how important this is. So, you know, find out what the pH is, find out what you need to do in order to correct that pH. And then finally, if you think about the scope to reduce grass demand or silage demand on your farm. So take steps now to really try and save this year's fodder as much as possible. So potentially if we get a good spring, that will be helpful. Don't carry any passengers in your herd or your flock. For example, if you're working with an autumn calving herd, then get them scanned and get any barren cows culled out of the system. Next slide, please. And just in summary, this message has remained in place for years and years and years. Well-managed grass remains the cheapest feed available on livestock farms. But this year more than ever, your planning is going to be essential. You want to try and make the most of this valuable resource, and it is still cost effective, as Debbie has shown. Think about your slurry as a resource. Don't think of it as a waste product. Put it on appropriately, and then from there, top up with your artificial fertiliser. Use the CAFRE crop nutrient calculator. I can't stress that enough. Aoibhinn has given you a flavour of how easy it is to use. However, if you are in a business development group, please speak to your CAFRE advisor and they can help you out with that. It's in my mind, this should be viewed as an essential tool this year when it comes to fertiliser planning. And finally, sort of the theme this evening has been expenditure on fertiliser must be clearly thought out. And that's the end of my presentation. Thanks for listening, and I'll hand back to Robert.
Many thanks, Rachel, for some very good practical actions there the farmers can take to make sure that every kilo of fertiliser count. I suppose, look, while none of us know what the future holds and concerns around fertiliser availability and whether we decide to sow it or not, the fodder situation could be tight next winter. And I think we all agree that running out of forage is a situation that nobody would want on their farm. Our final speaker tonight is Dr. David Patterson, who is a grassland agronomist with AFBI. David is going to discuss some of the longer term options currently available to farmers to reduce reliance on artificial fertiliser. So thank you, David, and over to you.
Okay, thank you, Robert, and good evening, everyone. I think tonight you've all been very patient, and you've heard a lot of good information from the science, from the economics, right through to the practical good practice on farms. And I think all of that information is helping, I hope, to show you how to deal with the impact of higher fertiliser costs this spring, and how to react to that at present, at this point in time. What I want to do is have a look a little bit further down the line into the future and consider alternatives to using chemical fertiliser on grassland. And I think it's also worth pointing out that it's not just about the financial, economic cost of fertiliser, but there's also an environmental cost of using chemical nitrogen on our grassland. And as we move and think towards lower carbon farming, one of the mitigations that we have available to us is to take a really hard look at the use and utilization of our chemical nitrogen that's gone into the system. And it's certainly one way of significantly reducing the carbon footprint of any farm, for that matter. So next slide. Thank you, Gillian. So in terms of reducing the reliance on fertilizer nitrogen, I want to take maybe a little step backwards, first of all, and have a think and a look at the species that are in our swards. And the first point there is thinking of ways and means of increasing the species diversity in order to deliver more sustainable grassland, delivering both good productivity in terms of the sward and good animal performance, but also delivering a sward that is resilient and environmentally suitable as well. So primarily what I'm thinking of there is greater use of legumes to fix biological nitrogen, and that's free, that's from the atmosphere. And the species involved are essentially white and red clover. There are other legumes which fix nitrogen as well, but those are the main two we'll consider tonight. Thank you. And in terms of increasing diversity, you'll see in the photograph on the left there a really good, healthy, thriving sward of perennial ryegrass, timothy grass, as well as white clover. And some of it's actually in flower there. So it's a very healthy, diverse sward and can reap some of the advantages in terms of savings of nitrogen fertilizer. Another step beyond that is the photograph on the right, which is basically the same type of sward with also red clover and introducing a new range of species of herbs into the equation as well, in this case, chicory and plantain. But increasing diversity in our swards as we look to the future, I think it's a step-by-step process. So for tonight, we'll just focus mainly on incorporating legumes. So next slide, please. And some of the features or the advantages in this case of grass white clover swards, as already I've briefly mentioned, white clover can substitute chemical nitrogen with fixed atmospheric nitrogen, but how much? You know, and when I look across a range of previous studies and trials and so on, the average that is achievable, there is a range, but the average is about 150 kilograms of nitrogen per hectare. And that's being fixed by the legume through the nodules in the roots, and eventually through a process of nitrogen transfer, that nitrogen becomes slowly available to the companion grasses and herbs, for that matter, growing alongside the clover in the sward. White clover swards, they're ideal as grazing swards because the clover itself is stoloniferous. By that I mean it creeps along the surface of the ground surface, and that contrasts with the more upright, erect growth habit of perennial ryegrass and other tufted grasses in the sward. So there's good compatibility there, is what I'm trying to say. And third of all, there's higher dry matter intakes from the stalk point of view, basically due to the higher digestibility of the white clover tissue. There's lower levels of the very indigestible cellulose and lignin in the clover tissue in comparison with grass tissue. Next slide, please. And just to let you see what we're talking about, the photograph on the top left is a young juvenile clover plant, which is approximately 4, 5, maybe 6 weeks old at the very most. And you can just about see when you look at the roots there, there's still the remnant of a taproot there that will eventually disappear as the clover plant matures. The photograph diagram at the bottom of the slide shows a clover plant, which is probably 2 to 3 years old. And you can see the stolons, these horizontal stems really growing along the ground surface. And then every now and again, a node at a node on the stolon pops up a leaf, which is what is grazed off by the livestock. Okay, next slide. And just taking a step across, we mentioned red clover a moment ago. Red clover is predominantly used as a silage crop for cutting. And generally speaking, it's not grown as pure red clover. It can be, but generally it's sown along with grass. A short-term mixture for silage cutting might be lasting maybe 3 to 5 years perhaps, and that's usually sown alongside hybrid ryegrass. A longer-term mixture, 8 to 10 years of lifespan, of productive lifespan, might also include tetraploid and diploid perennial grasses, late maturing types, and also white clover. So that as the red clover declines in the sward at years 3, 4, 5, then those other components are still there in the sward to make it a productive lifespan of, as I say, of 8 to 10 years. In terms of productivity, a good thriving grass red clover sward can do 14 to 16 tons of dry matter per hectare and deliver 18 to 22% average crude protein. And there's the downside. At last, it's a short-lived perennial, is what it is. So it persists in the sward only for, say, 2 to 4 years, depending on the management of it. Because it's got a very upright growth habit, it's suitable for silage on one hand, but it's got a slightly elevated growing point, which sits just above the ground surface. And that is what makes it vulnerable to poaching or too much tramping or even tractor wheel treading. Can actually damage that crown tissue, and the plant doesn't recover from that. It's not like white clover, which can creep and cover the spaces and the bare ground. Next slide, please. So getting back to grass white clover, how do these grass white clover swards perform in beef farming systems? And I've just picked out some examples from the literature here from AFBI research and Chagas research over the years. Top line there, 4-year study in AFBI, and there was a grass white clover with 50 kilograms of nitrogen, and that was it for the season. So grass clover with 50 kilograms of nitrogen, and that produced about 86% of the grass yield of a grass plus 360 kilograms nitrogen sward. So you can see there straight away the typical sort of yielding capacity, even with a relatively small amount of artificial nitrogen going onto the system. Second line on a 5-year study, grass white clover with no chemical nitrogen whatsoever this time, and that was able to support 85% of the stalking rate of a grass-only sward with 400 kilograms of nitrogen. Now, these are experimental trial results, so that's why they're going to extremes of nitrogen fertilizer levels. And finally, there were 3 studies done at Grange down south, where they had grass white clover swards, again with 50 kilograms of nitrogen per hectare in the early part of the season. And that was able to produce 90% of the animal carcass gain per hectare of a comparable grass plus 220 kilograms of nitrogen per hectare. And that, bearing in mind the information you heard in the earlier talks, that's maybe coming closer to reality in terms of comparing with grass-only swards. Okay, next slide, please. But as always, there are some challenges and some downsides. And there's 4 or 5 points here that the clover performance is probably less predictable in terms of spring yields of clover. There's certainly less out of season growth. We've had a particularly good back end this past season, and grass has slowly but surely grown over the winter period. Clover, generally speaking, won't do that. There's also a third point there, perception of poor clover persistency. In terms of occasionally you'll get a bit of a clover crash in a particular field for no real explainable reason. There's also incidences of bloat, and that can be quite variable across farm to farm, field to field conditions. And finally, another challenge is even getting the clover established. If you're starting off with virtually a grass only type farm and you're wanting to make a switch over, it's establishing clover, how to do it into both new swards by reseeding and trying to do it into existing swards by stitching or slot seeding the clover into the sward. And just returning briefly, what about the environmental impact that we mentioned at the start? I think there's 3 salient points here. That nitrogen fixation that we've mentioned a couple of times already is free. The rhizobia and the roots do the fixation. But also from a calculation point of view, it's considered that fixed nitrogen is considered carbon and energy neutral, which is a plus point. From a greenhouse gas emissions point of view, the second point, if you're using much lower levels of chemical fertilizer, that same fertilizer is the main source of nitrous oxide emissions in regularly fertilized grassland. And finally, the carbon footprint. A life cycle analysis that was done in AFBI over 10 years ago now compared dairy origin beef finishing systems either using grass clover or using grass plus 150 kilograms of nitrogen. And it showed whenever they calculated all of the inputs and outputs and done the equations, that showed there was a 19% reduction in carbon footprint with the grass clover system. So just in summary, I think looking to the future, grass clover swards can substitute quite a bit of fertilizer nitrogen and improve herbage digestibility at the same time. But being realistic, there are establishment and persistency challenges, and we have to figure a way through those problems. And ultimately, yes, it's a different type of management strategy to grass-only type swards. And you have to adapt the management in order to achieve a healthy, productive, sustainable grass clover sward in order to be able to reap the rewards of the financial savings as well as the environmental benefits. Maybe on that point, Robert, I'll try and keep the time and stop there. Thank you.
Thanks very much, David. No, thank you. There's some really good information there on the potential of, in particular, clover to supply much of the nitrogen actually that grass crops require to achieve good yields. So look, thanks to all the panelists for their presentations tonight. They were really good. So that brings us to the next part of this evening, which is our question and answer session. And while we do our best to answer as many of the questions as we can, I see there's over 60 questions in there, so we'll not get through them all, but we will get answers to them all. And all the questions and I suppose more importantly, all the answers will be posted up onto the CAFRE, AFBI and AgriSearch websites after the event. At this point, I'd like to welcome Jason Mcfern to the panel. Jason is a senior business technologist at CAFRE and manages the CAFRE benchmarking program. So just at this point, Jason, I haven't heard from you to date, but I see a question in there. My merchant requires cash on collection. What is the most cost-effective way for my business to manage this hit on cash flow?
Okay, thanks, Robert. Good evening, everybody. Yes, so that's a familiar comment that we're hearing at the minute. Certainly, cash on collection is something that folk are being asked for. In some cases, even a deposit. I've heard also when fertilizer is being ordered. So I suppose it follows the same theme that many of the panelists have already been talking about this evening, and that's about future planning, trying to think ahead what is needed, so you're not caught out financially. So I suppose first, excuse me, first and foremost, talk to your merchant, see what they're willing to do with you, see how flexible they are in terms of payments, just so you know up front exactly what is required, and then that allows you to plan. So I suppose a little bit about like what Rachel was talking about there, thinking over the year ahead and thinking, well, what are the cash needs for the business? So we call that a cash flow, what money is coming in and out, and that allows you to think, well, can I ensure that there's money there to pay what I need? And then can you review some of that spending? Do you absolutely need to spend all of that money over the next few months? And if you don't, can you delay it without having any knock-on effects? Then I would be doing that, and that might free up something. In terms of making sure then that money is available, if there's an overdraft facility, obviously that is something that you can look at and manage and take that up to the limit. Obviously not over the limit of the overdraft. And then if all those options have been looked at and there's still a need for money to pay for fertilizer, it's a matter of speaking to a finance provider, your bank, or whoever it is you get your finance from. And the thinking there is that it will be a short-term loan, so you probably won't get your overdraft extended, but a short-term loan would be made available in many cases to allow you to manage that.
Thank you, Jason. Thank you. Yeah, well, we've only 10 minutes left, so we'll race on through them. Debbie, the next one for yourself. What impact will cutting my nitrogen application have on my total grass production? And is it worthwhile splitting the main nitrogen application? And is it worth considering that for this year?
Okay, as a rule of thumb, if we were going to cut nitrogen fertilizer application by about 100 kilograms of nitrogen per hectare, which is about 80 units per acre, that's going to cut your grass production by about 2 tonne. So there's a fair sizable decrease in the amount of grass that you're producing, particularly if you apply that over the whole of the grazing platform, for example. So if you're 20 hectare grazing platform, that's 40 extra tons of forage or of feed that you need to find somewhere else. And that can either be done by buying in concentrates, but it's very costly to do that, or by trying to look for additional land. Sorry, Robert, the second part of your question there.
Yeah, was it worthwhile splitting the nitrogen application this year?
Yeah, in terms of splitting nitrogen applications throughout the season, there generally is the theory that little and often is a better approach, because you're then applying the amount of nitrogen required at the time when the plant needs it. So if we are applying a small amount after each grazing cycle or after most grazing cycles, we reduce the risk of losing nitrogen either through leaching or to the atmosphere by having too much nitrogen there that the plant's not available to take up all at the one time. So yes, the theory is that in general, trying to split nitrogen applications can minimize that risk of nutrient loss and hopefully improving your nitrogen response rate.
No, thanks, Debbie. There's another one in here actually, and it's around urea and liming. I read I can't sow urea after liming. Is that right? And there's another one linked to lime around, is there any effect lime can have on silage quality?
So on that one, so if you've applied lime, in general, you're required to leave about 3 months between the time that you spread the lime and between urea applications. If you're doing it the other way around and applying urea first, you only need to leave about a 10-day window. So if you have applied or are planning on applying lime already this season, urea, you will have to wait quite a while to apply that. So you'd have to go with something like CAN instead. Protected urea, I think there might be less of a window that's required, but I think there's a wee bit more work needed on that. So it'd be just something to check out and ask your fertilizer rep. In terms of the impacts on ensiling, yes, if you apply lime to silage ground in reasonably close proximity to when you're cutting the silage, it can have a negative effect on ensiling, because the lime can sort of inhibit some of the acids developing in the ensilage process. So if you have really got lime to apply, ideal time to apply it is at the back end of the season to silage ground, so that you're not influencing it for the next year.
Super. Rachel, there's a question in here about the prioritization of slurry, and where should farmers prioritize the spreading of their slurry?
Okay, thanks, Robert. So when you're thinking of your slurry, your silage ground really should be the priority there with your slurry application. So there's a lot of nutrient value available in that slurry. It comes from, a lot of it comes from the P and K, so you want to try and maximize that value. So you want to try and replace some of the offtake from your silage crops with your slurry. So I would say try and portion as much of your slurry off to your silage ground as you can.
Thank you, Rachel. Evan, someone has submitted a question here about what is meant by a high P manure.
Yes, Robert, a high P manure is a manure with a high ratio of P to phosphate content. So that would be a reading of over 0.25. So it would, or a ratio of over 0.25. And typically that's your pig farmyard manure, horse farmyard manure, the litter from adult poultry, from adult birds such as layers, broiler breeders, and so on. And then anaerobic digestion, obviously that's another one that falls into the high P manure category. And when dealing with high P manures, you have to have a fertilization plan. You must show a crop need before applying.
No, thank you. Just when you mentioned anaerobic digestate there, Evan, there's a question in around it about what are the main considerations to be taking before spreading digestate on the land? Yeah,
well, if a farmer's importing digestate, they should obtain a nutrient analysis from the digester owner. That must be supplied with the digestate. The farmer should then prepare a fertilization plan and identify if there is a crop need, and only apply where there is a phosphate need there. They also must use low emissions slurry spreading equipment, and that came in last year, so has been in effect since February of last year. And then as with applying all fertilizers, they should keep records of that for inspection.
Thank you. David, there's one here about would there be any benefit to growth this year by sowing clover this spring, or when is it best to stitch in clover to get the best benefit?
Yeah, no time like the present to start planning it, at least. Certainly for overseeding, if it was pushed, I would say it's probably more successful after the peak of grass growth. Okay, so April, May, June is probably the peak of grass growth. If you're trying to put it into an existing, otherwise healthy grass sward, I would leave it until after that. And then you're looking for all the right conditions of moisture and heat and everything else, and preparing the grass by trimming it well back, right down to almost soil level, creating a little bit of tilt at the surface. So that'd be later part of the season. If you were reseeding or doing some sort of surface minimal cultivation, you could do that in the spring for sure, and put in an entirely new sward that way of grasses and clovers in the springtime.
Thank you, David. Debbie, does cutting the amount of nitrogen applied to a silage crop have any impact on the protein content of the silage? And another one, just when is sulfur best spread? So first, second cut, or?
Yeah, so so yes, reducing the amount of nitrogen that you apply will impact on the crude protein value of your silage. So I think typically from studies that were done at AFBI a number of years ago, if you were applying, typical RB209 recommendations for nitrogen fertilizer, you could get sort of 14% crude protein in your silages. Once you reduce that down to about 50 kilograms less per hectare, so then you're talking about that bringing down to about 13.9. And when they reduced it by 100 kilograms nitrogen less per hectare over the course of the year, they averaged their crude protein was down to about 13.3. So you're losing at least a percentage point in there in terms of crude protein, which you've got to buy in. So it will impact it on it. That way for certain. In terms of applying sulfur, yep, I mean, at the minute, I think we discussed a wee bit last week actually, the sulfur prices haven't gone up that much, but a really valuable addition to have. I think sulfur actually after nitrogen is one of the most readily leached nutrients, but it's one of the main 5 that's required by the plant. So obviously main times for application of sulfur, certainly in the springtime, but right the way through the season, it's valuable to add in as well, because it is something that's required by the crop, and as an insurance policy, adding it in there, it's relatively cheap to do so for the impact that it has.
No, thanks, Debbie. And probably the last one tonight, Rachel, someone has asked, what immediate steps can I implement in my farm to offset high fertilizer prices?
Yep, that's a good one, Robert. I would say look at your soil fertility levels straight away and get your soil analysis done. It's a very cheap test. It gives you a wealth of information, and in particular, the pH level in the soil must really form the basis of this. If you have to implement a liming program, get that done, work from there. But also an important one is to consider the infrastructure really on your farm. I'm thinking about the implementation of the paddock grazing system. So what about access to fields and paddocks? How can you split them up? Electric fencing, for example, water supply, all those sorts of things come into play as well. And it is amazing how much of a benefit farmers do see once they start to just even split fields in 2. We don't have to go the whole hog this year, but it's about, trying to implement it in baby steps and trying to get that system right. But first and foremost, get the soil fertility levels right. And I think all of the presentations this evening have, touched on that and shown how important that is. So that pH level must be correct in order for everything else to fall into place in terms of especially your fertilizer application.
Thanks, Rachel. Look, thanks, folks. Thanks to everyone for sending in all your questions. And thank you to the panel for providing such good comprehensive discussion around them. So thanks very much. Okay, folks, then to begin to bring tonight's event to a close, I'd like to remind you then just of the key take-home messages from our speakers this evening. Thanks, Gillian. Yep. So the recent fertilizer price increases will significantly increase the cost of reducing both grazed grass and grass silage. And unfortunately, that's how that market has went due to the fertilizer market. However, good quality grass remains the cheapest feedstuff available on farms in Northern Ireland, and in most cases, it is still economical to apply up to 200 kilos of nitrogen per hectare, providing that the grass is well utilised. Maximise grass response from fertiliser applied through good management practices. So the first of those, soil health. So making sure your pH, phosphate, potash statuses are at optimum levels, and also, folks, don't forget about the sulfur. Timing of fertilizer application is critical. So keeping an eye on soil temperatures, the weather forecast, and trying to predict when the grass response is likely to be good, and then looking at your utilization of your grass. So there's no point growing grass if it can't be utilized as far as you can, and it's vitally important this year to minimize wastage at every point in the process. So it's going to be a good year to be measuring grass and therefore managing it. So if your grass covers get ahead of you this spring, this year will be a good year to try and get in there and remove some of those covers as bales for use later in the year. Slurry and manures have never been more valuable, and the planning of their application is critical. Concentrate the spreading of them as where the need is greatest, and therefore hopefully the response will be greatest as well. There's lots of excellent information on nutrient management planning on the CAFRE website, as well as links to the various online tools to help you along. Longer term then, we're going to have to capture the potential of clovers to reduce our reliance on nitrogen fertilizer, both from a cost saving point of view, but also as we move towards reducing our carbon emissions from across our farms. Folks, this event and the event last week focused at dairy farmers was the first in a program of targeted PR to help industry deal with the issue of very high fertilizer prices. Please keep in touch with the CAFRE social media presence and the local farming press, where we will be publishing further articles to help you make informed decisions around fertilizer application this year. While we're talking about PR, and if you found tonight's webinar useful, please note the upcoming events to support the development of the local industry. These will all be delivered online, and registration can be done through any of the partners' websites. So tomorrow night, we have the Arable Conference, which is about understanding carbon and arable rotations. The 2nd of February, and that is Wednesday night, with the Sheep Conference around focusing on pasture productivity. And on Thursday night, then Grass Check GB Conference. And you can see there's other events there the following week and the week after that. So folks, stay in touch with the social media side of AFBI, AgriSearch and CAFRE to keep in touch with those. My sincere thanks to all our panelists and everyone for joining us tonight and submitting plenty of questions. So there's lots of good information and discussion, and hopefully it'll be very helpful. And lastly, please take a few moments to complete the short survey following this event. The results will help us in the planning of any and all future events. Thanks again and good evening, and we hope to see you at another webinar soon. All the best. Bye now.